Today we have to study the writing of chemical compounds. Okay, writing chemical formula. How we can write the formula of a compound. There's a question. What are the rules to follow while writing a chemical formula? There are some rules. What are they? There are mainly three rules. First one, the valencies or charges on the atom must be valence. In the previous class, we studied about the charges of different elements. So, the charges in between the two elements in a compound must be valence. Second one, when a compound consists of metal and non-metal, then name or symbol of the metal is written first. For example, CaO. CaO, this calcium is metal, so we write the calcium firstly. In the case of sodium, NaCl, sodium is written firstly. Then Fe is metal, so it is written in the first letter. Then in compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. This is the example. Ca is metal, so it is written at the first. Then OH is polyatomic ion. OH is polyatomic ion. It is an ion. OH minus is an ion. It consists of two elements, oxygen and hydrogen. So it is polyatomic ion. So for a polyatomic ion, the number indicate the ratio should be written in a bracket. So this OH twice is enclosed in a bracket. Otherwise CaOH2 is not a method. CaOH twice. This twice is common for oxygen and hydrogen. It is correct. Okay, so we have to do some examples for writing the chemical formula. How these are the rules, but how we write it? First example, HCl. It's a compound. HCl is a compound. So in this case, the charge of hydrogen is positive, H plus and Cl minus. Charge of chlorine is minus. So positive is written at first and chlorine is written as the second. What is the valency of hydrogen? Valency of hydrogen is 1. The valency of chlorine is also 1, because for chlorine there are 7 electrons in the outermost shell, so 1 electron is needed to complete the octet. So valency of chlorine is 1, hydrogen is also 1. So interchange these valencies and write H1Cl1. H1Cl1 is the representation, but we don't need to write 1 as the suffix, not needed. So HCl. Second one, H2S. What is the valency of hydrogen? Is 1. Valency of hydrogen is 1. H and S, the valency of hydrogen is 1. Valency of sulfur. Valency of sulfur is 2. Valency of sulfur is 2. So interchange these valencies and write H2S. Interchange this H2S1, but we don't need to write 1. So H2S. Okay. So you should study the valency of each element to write the chemical formula. Okay. CCl4. C and Cl. Carbon and chlorine. Valency of carbon is 4. Valency of chlorine is 1. interchange this. So C1Cl4. C1Cl4. We don't need to write this one. So CCl4. This is the method. Next one. MgCl2. MgCl2. Valency of magnesium is 2 because it included in the second group in the periodic table. So magnesium 2, chlorine 1. Interchange this. And we get Mg1Cl2. Cl2. We don't need to write this one. So MgCl2. Next one. L2O3. What is the valency of aluminium? L2O3. What is the valency of aluminium? What is the valency of aluminium? Valency of aluminium is 3. Valency of oxygen 2. You should study the valency of each compound, each element. So interchange this. Al2, then O3. L2O3. Next one. Okay, next one. CaO. CaO. What is the valency of calcium? Valency of calcium is 2 because it included in the second group in the periodic table. Hydrogen, lithium, sodium, potassium, rubidium, cesium, magnesium, calcium. Magnesium, calcium. It is included in the second group in the periodic table. So valence is 2. Oxygen valency 2. So interchange this and Ca2 O2. Ca2O2 is the correct answer, but we can cancel these two because it is common. So 2 by 2, 2 by 2. Divide this 2, divide 1 or 1. We don't need to write. So CaO is the answer. CaO. Okay. You can take the ratio of these two numbers. If it is common, then you can avoid it. CaO. Next one. NaNO3. NaNO3. So first you have to write the valency of sodium. Sodium valency is 1. Then NO3. Valency of NO3 is minus 1. So 1. So interchange these two. Na1, NO3, 1. But you need not to write the 1. So NaNO3. Okay. The next one. CaOH twice. Ca and OH. Why it is a polyatomic ion? It have a valency or ion charge -1. What is the valency of Ca? Hydrogen is important. Calcium. Calcium is valency 2 and the OH valency 1. So interchange this Ca1, Ca1, OH twice. We need not to write this one COH twice. Then next one Na2CO3. NaCO3. What is the valency of sodium? Sodium valency 1. Then CO3 2. Valency of CO3 is 2. If you didn't know, you should study from that table that we discussed in the previous class. Okay. Na2, Na2, CO3 1, CO3 1. But you need not to write this one. NaNO3, Na2, NO3, Na2, CO3. Next one. NH4 twice SO4. These are examples only. NH4, ammonium, is a valency 1. SO4, 2 minus, that means 2. So, NH4 twice and SO4 1. But you need not to draw this one. So, you can write the chemical compound name. You can write the chemical formula of different compounds in this way. Then what is molecular mass? This is an important question. What is molecular mass? In the previous class we studied the atomic mass and also we studied the atomic masses of some compound and some elements. Okay. It is the sum of atomic masses of all atoms in a molecule expressed in atomic mass unit. It is the sum of all. It is the sum of the atomic masses of the atoms in a molecule. You have to find the atomic mass of H2O and HNO3. Calculate the relative molecular mass of H2O and HNO3. First, find the molecular mass of H2O. What is the atomic mass of H2? What is the atomic mass of hydrogen? What is the atomic mass of hydrogen? 1. So, 2 hydrogen molecules. 1 into 2. Plus, what is the atomic mass of oxygen? 8. What is the atomic mass of oxygen? 16. So, 1 into 2 plus 16 equal to 2 plus 16 equal to 18 atomic mass unit. 18 AMU is the molecular mass of H2O. It is the molecular mass of H2O. So, molecular mass means the sum of atomic masses of the atoms in a molecule. Then HNO3. HNO3. What is the atomic mass of hydrogen? Is 1. So 1 plus. What is the atomic mass of nitrogen? 14. Then what is the atomic mass of oxygen? 16 into 3. 3 atoms of oxygen is here. So 3 is 16. That means 15 plus 16 into 3. That means 48. 48 plus 15. That means 63. Okay, 63 AMU. Molecular mass of HNO3 is 63 atomic mass unit. Then take another example, HCl. Another example. Molecular mass. Find the molecular mass of HCl. HCl. What is the atomic mass of hydrogen? 1. Atomic mass of hydrogen 1 plus atomic mass of chlorine 35.5. So molecular mass of HCl is 36.5 atomic mass unit. Okay. Then we have to find the molecular mass of H2SO4. So you should study the atomic masses from the table that I explained in the earlier classes. It will help you to find the molecular mass. Okay, what is the atomic mass of hydrogen? 1. But here 2 hydrogen atoms. 1 into 2. What is the atomic mass of sulfur? 32 plus 16 into 4. 16 into 4. So sum is 2 plus 32. 34. 34 plus 16 into 4 is 64. 34 plus 64 is 98 AMU. 98 AMU is the molecular mass of sulfuric acid. Molecular mass of H2SO. So you can find the molecular mass of any compound in this. Okay, then what is formula unit mass? What is formula unit mass? It is similar to molecular mass. Okay, entirely similar with the molecular mass. The formula unit mass of a substance is the sum of the atomic masses of all atoms in a formula unit of compound. In a formula unit of compound. So you need to take the compound and find the formula unit mass of that compound in same way as that of molecular mass. What is the difference between molecular mass and formula unit mass? There is only one difference. The difference is that formula unit mass is used for ionic compounds and molecular mass is used for other compounds. So the computing way is similar, but we commonly use formula unit mass to ionic compounds. Example NaCl, CaCl2. Because this sodium share this sodium transfer electrons to chlorine. This ionic compound. So what is the atomic mass of sodium? We studied it 23 and the chlorine 35.5. So sum is the formula unit mass of NaCl is 58.5 AMU. Then CaCl2, calcium, atomic mass is 40, Cl2 2 into 35.5, sum is 40 plus 71, and the answer is 111 AMU. Okay, so there is only one difference. It is commonly used for ionic compounds. Okay, that is the only difference. The things, the calculating way is same. Okay, then we are going to discuss a new concept. It's a mathematical problem. What is mole concept? Okay, what is define one mole? Define what is one mole? Define what is one mole. One mole of any species, any atoms or molecules, ions or particles, is that quantity in number having a mass equal to its atomic or molecular mass in grams. That means if you take carbon in a dish, it's carbon, okay, carbon. The molecular weight or the mass of this carbon is 12 gram. What is the atomic mass of carbon? It is 12 AMU. Okay, atomic mass of carbon is 12 AMU, and I take 12 gram of carbon molecules, carbon compound. I take 12 gram of carbon in a dish or in a beaker. So this quantity is called 1 mole because it is same as that of the atomic mass. So mole, 1 mole of any species. Here I take carbon atom. So 1 mole of carbon is that quantity in number having mass equal to its atomic or molecular mass in grams. If you take 12 gram of carbon, then it is 1 mole. If you take 1 gram of hydrogen, then it is 1 mole. Okay, because the atomic mass of hydrogen is 1. If you take 16 gram of oxygen, then it is 1 mole. So 1 mole is the quantity number having mass equal to its molecular mass. Another concept. What is Avogadro's constant? There is a new constant. What is Avogadro's constant or Avogadro number. It is the number of particles, atoms or molecules present in 1 mole of any substance is fixed. 1 mole of hydrogen contains 6.022 into 10 raised to 23 atoms. This is a number. This is Avogadro's number. Any substance 1 mole contains this number of atoms. That number is constant, is fixed. It's called the Avogadro's number. So 1 mole is equal to 6.022 into 10 raised to 23 number. This is the quantity. 1 mole contains this number of particles. It's a huge amount. 10 raised to 23 is a huge amount. Here we say 1 dozen is 12 number. In the same way, 1 mole is, this is the Avogadro number. Then what is gram atomic mass? What is gram atomic mass? The mass of 1 mole of a substance is called gram atomic mass. The mass of 1 mole of substance is called gram atomic mass. So what is the atomic mass of gram atomic mass of hydrogen? Hydrogen's molecular mass is 1 gram. So this 1 gram indicates gram atomic mass. Okay. What is the difference between gram atomic mass and molecular mass? There is only one difference. There is only one difference. It is that the unit of molecular mass is represented as AMU, but the unit of gram atomic mass is represented as gram. There is only one change. Hydrogen's atomic mass is 1 AMU and gram atomic mass is 1 gram. That is the difference. Okay. Then who introduced the word mole? The word mole was introduced by William Oswald at 1896. Okay. So William Oswald is the person who introduced mole firstly. Then we have to do some problems. Okay, this is the question. Calculate the number of moles of the following. First one, 52 gram of helium and 12.044 into 10 raised to 23 number of helium atoms. Okay, so look at the first question. 52 gram of helium. We have to calculate the number of moles. We have to calculate the number of moles. Just you can think the molecular mass of atomic mass of helium. It is 4 and 52 gram is the given value. So you can write the answer directly. 52 divided by 4 is the answer. 52 divided by 4 is 30. Is the 13 moles is the correct answer. But how you get it? That is the step. First you have to mark the number of moles as small n. You can represent the number of moles, that is the answer, as small letter n, and the given mass is small letter m, molar mass is capital M, given number of particles is n, Avogadro number is n0. It is the representation letters. It may help you. That is why I write here. This is the way to solve this problem. Okay. So then the question, 52 gram of helium. Then there is an equation. Number of moles is equal to given mass by molar mass. Given mass is represented as small m. Molar mass is represented as capital M. So m by m. What is the answer? Molar mass small n is equal to small m. Small n is equal to small m, means given mass 52 divided by capital M, or molar mass, it is It is 52 divided by 4, that means 26 divided by 2, that is 30. This is the number of moles. So 52 grams of helium contains 13 moles of helium. Okay. Then another one, 12.022 into 10 raised to 23 number of helium atoms contains how many number of moles? That is the question. Answer is 2. You can write, you can find in simple way, but there is some equation. Okay, it is the second one. This equation, number of moles is equal to number of moles, same. Number of moles is equal to given number of particles divided by Avogadro number. This is the another equation to find the moles, number of moles. Given number of mass. Here the number is given. So given number divided by Avogadro number. Given number is represented as capital N. Avogadro's number is represented as N0. So substitute it. 12.044 into 10 raised to 23 divided by 6.022 into 10 raised to 23. It is the Avogadro number. So just cancel it. This cancel, and it is the double of this. Okay. This and this cancel. Answer is 2. 2 is the answer. 2 number of moles of helium is present in 12.044 into 10 raised to 23 number of helium atoms. Okay, another question. Calculate the mass of the following. Calculate the mass of the following. 0.5 moles of N2 gas. Then 0.5 moles of N atom. 3.011 into 10 raised to 23 number of atoms, N atoms. 6.022 into 10 raised to 23 number of nitrogen molecule, N2 molecule. Here there is a confusion. N2 gas is a molecule. There is a difference between molecule and atom. Nitrogen is atom, N2 is molecule. So molecular mass and atomic mass. What is the atomic mass of nitrogen? Atomic mass of nitrogen is 14 mu or 14 gram. Gram atomic mass is 14 gram. Okay, 14 gram. Then molecular mass of nitrogen. One molecule of nitrogen is N2. So N2 means 14 into 2 is equal to 28 gram. Okay, 28 gram. It is the molecular mass, it is the atomic mass. Then if you get this, then you can substitute. 0.5 moles of N2 means mass is equal to molar mass into number of moles. Molar mass is molar mass. Here N2, so 28 equal to 28 into number of moles, 0.5. 28 into 0.5 means 14 gram. So answer is 14 gram. Okay, next one. 0.5 moles of N atoms. 0.5 moles of N nitrogen atoms. So here also M into N, but here M is, capital M is 14 gram into 0.5. Answer is 7 gram. Okay, answer is 7 gram. And the third one. Here the number of moles. Number of moles is to find. Then we calculate the mass. So number of moles. How many number of moles? You can calculate it in mind, but answer is 0.5. But how? Number of moles is given number divided by Avogadro number. This number divided by Avogadro number. 3.011 into 10 raised to 23 divided by Avogadro number is, answer is 0.5 because it is the double of this. So answer is 0.5. Small n is 0.5. Number of moles is 0.5. If you get the number of moles, then you can calculate the mass by using this equation. M is equal to m into n. Capital M is the atomic mass of 40 into 0.5. Answer is 7 gram. Okay, answer is 7 gram. Then the last one. Fourth one, the last one. 6.022 to 23 nitrogen molecule. It's a molecule. So how many number of moles small n is equal to how many number of moles? Given number 6.022 into 23 divided by Avogadro number. Avogadro number is 6.022 into 23. So answer is 1. 1 mole of nitrogen molecule is present. Then we have to calculate mass. Mass is molar mass into number of moles. Molar mass is 28. 28 into number of moles. That is 28 gram. This is the answer. 28 grams is the answer. There is one more question. Calculate the number of particles in each of the following. First one, 46 gram of sodium atoms, 8 gram of oxygen molecule, 0.1 mole of carbon atoms. You can do it in simple way. Just think about it. 46 gram of sodium atom. Here, sodium. What is the atomic mass of sodium? 23. 23 gram. So, in 46 gram, it includes 2 mole. 2 mole means, and 2 mole means 2 into 6.022 into 10 raised to 23 number of atoms. 2 into this means 12.044 into 10 raised to 23 is the answer. Is the way. But if there is an equation, the number of atoms is equal to given mass by molar mass into Avogadro number. That is capital N is the number of particles that we have to find is equal to small n divided by capital N. Given mass is 46 divided by molar mass is 22 into Avogadro number. Avogadro number is 6.022 into 10 raised to 23. Then the answer is 2. So 2 into 6.022 into 10 raised to 23. Answer is 12.044 into 10 raised to 23. The answer. Okay, so if you study this equation, then you will get it. Otherwise, you can think and find the answer. Which is the simplest way for you, then you can use it. Second one. 8 gram of oxygen molecule. Don't confuse in between atom and molecule. Here oxygen molecule. Oxygen molecule means O2. So molecular mass of oxygen is 16 into 2, that is 32 gram. Molecular mass of oxygen is 32 gram. 8 gram of oxygen molecules. How many number of moles is present? 1 by 4th mole is present. Then 1 by 4 into Avogadro number is the answer. Okay, just do it in the same way. N is equal to m divided by capital M into Avogadro number. Given mass is 8, molecular mass is 32 into 6.022 into 10 raised to 22. Answer is 1 by 4 into 6.022 into 10 raised to 23. 1 by 4 into that Avogadro 6 by 4. Then 1.5 into 10 raised to 23 is the answer. If you stop this, it's also correct. Okay, 1 by 4 into 102 into 10 raised to 10 raised to 23 is enough. Okay, third one. The answer of third one. 0.1 mole of carbon atom. 0.1 mole of carbon atom. So what is the atomic mass of carbon? 12 gram. 0.1 mole means 1.2 gram. Okay, 1.2 gram of carbon is present. Then calculate the number of particles. Number of particles is the question. So 0.1 into 0.1 into Avogadro number 6.022 into 10 raised to 23 is the answer. 0.1 into this means 0.6022 into 10 raised to 23 is the correct answer.